Welcome back. Thank you for everybody who did so well on the Chapter 11 assignments. Now, I'll say this, chapter 12. This goes out to all of you who are taking the Advanced Placement exam this year. Chapter 12 will not be on the Advanced Placement exam this year. However, it is still on the syllabus for our dual credit course through Missouri Valley. So we are going to do chapter 12. It's only two sections, okay, in chapter 12. The topic for chapter 12 is called chi-square tests. Okay, now let's get this out of the way right away. There are a couple different ways you can write chi-squared test. I can write the word like so, chi-squared test. But then another way that you'll often see it written is with a capital chi squared like that. Okay, so if you see something, if you see this phrase written somewhere, this doesn't say the x squared test. Okay, it says the chi squared test. Okay, so chi squared test, chi squared test. Now there are three different chi squared tests that we'll learn in this chapter, and the first section only talks about one of those three, and it's called the chi-square goodness of fit test. And I'm going to go ahead and write that up here as well, so that you'll know what it looks like when you see it written somewhere. I could write this, for instance, as the like so. That says the chi-squared goodness of fit test. Then I could also write just the chi-squared GOF test. Okay, now we don't say chi-squared golf test, it's the chi-squared goodness of fit test. And it's this second thing, that's the way you'll see it on your TI-84 when you run that. Mr. Dinosaur, I love you so much, but just rest for a little bit, okay? Now, it is difficult to talk about the chi-squared test without talking about the subject of cereal and candy. And cereal is really too difficult for me to keep up with. Lucky Charms, for example, Fruit Loops, for example, but Lucky Charms, when I was young, Lucky Charms consisted of pink hearts, yellow moons, green clovers, and blue diamonds. But it's my understanding now that there are all sorts of different marshmallows in Lucky Charms. So I don't have any Lucky Charms. Okay, never did. Fruit Loops come in different colors. But think about your favorite cereal, maybe. For instance, maybe your favorite cereal is Lucky Charms. Well, what's your favorite type of marshmallow? Do you get more of those than any other type of marshmallow? Or do you get your least favorite type of marshmallow more than the others?
Is there a different flavor in marshmallows?
I don't really know. It's a good question, Teddy. Another
Dinosaur wants some Skittles.
well, let me ask you a question, Teddy. Do you like M&Ms?
Of course.
What's your favorite color of M&M?
Blue?
Blue? See, when I was a kid, they didn't even have blue M&Ms. My favorite were green M&Ms, and they were very rare, it seemed. Now, people argue, well, all M&Ms taste the same. Agreed. That doesn't mean they're as enjoyable to eat. No. Okay, that they're all equally enjoyable to eat. Now, one thing that probably nobody would argue with is the different Skittles, though, have different flavors. And I've got a whole bunch of Skittles here. Some random Easter bunny brought candy to our neighborhood on Sunday, and so my kids got a bunch of Skittles. I don't like Skittles. I don't know if my kids like Skittles.
I like Skittles.
They're
So-
kind of
I like Skittles, and the dinosaur likes Skittles.
the taste is objectionable. Okay, but they do look pretty. especially when they're all mixed up like that. Now I'm gonna bring these Skittles over here. Now let me. I've been kind of rambling on about cereal and such. Fruit Loops come in different colors as well, and you know, are they all? Do all colors occur with an equal frequency? That's the question. Do green Skittles occur as often as red Skittles or orange Skittles or purple Skittles? 1, 2, 3, 4, 5. I think I count 5 colors of Skittles. Okay. And one question that we might be interested in is, do all the colors of Skittles occur with equal frequency? Well, I don't know, but we can investigate. Okay, and it's that type of question that a chi-squared test is designed to provide analysis of. And we're gonna do some analysis here. I have no idea how it's gonna turn out, but I'll bring this plate of Skittles over and Teddy, you probably don't have to move the camera. Just look through it and see if you get that dinosaur. Okay, so do they look okay here? Can you see the Skittles?
A little bit higher. Okay, a little.
If I tilt it much
more.
more.
Okay, there. Yeah, I can see them.
So yeah, a bunch of Skittles. Now, the first thing I'm going to do is, because I'm going to pretend that I randomly selected, okay? And now pay attention here. I'm going to pretend that I randomly selected these Skittles from a nationwide search for Skittle packets, okay? So these are truly a random sample of Skittles. Now, that's a false assumption here, but it's one that's necessary. I have to have taken a random sample from the population of interest, where the population of interest is all the Skittles manufactured in the United States or the world. Okay, so now what I'm going to do is I'm going to divide these into their colors. So you probably can't see what I'm doing here, but I am separating the red Skittles from the rest of the Skittles. Okay, I'm making a pile of reds.
Dinosaur likes green Skittles.
Got it. Well, Dinosaur can have all the green Skittles he wants when this lesson has concluded. Okay, now I'm on orange now. Okay, if you want to fast forward, this will probably take me about another 20 seconds of sorting here.
So can I do entertainment?
No. But thanks for asking. Okay, I'm on the yellow. This is going pretty quickly, actually. There's a lot of yellow ones. I can tell you that right now. Teddy, are they lemon flavored?
Yeah, I think so. My dinosaur's favorite are green. Mine are green too.
Well, you're not going to get me to eat a Skittle.
Oh, I didn't give one to me.
After.
After.
Okay, just about finished. Okay, I have concluded the sort. Alright, they are now sorted into colors, this random sample from the population of all the Skittles produced. So now, what I'm going to do is, remember, I'm going to try to run a test to see if there is evidence that not all the colors are produced equally. Okay, we're going to go into this with the initial assumption that all of the colors of Skittles are produced with equal frequency. Okay, they make just as many green Skittles as they do purple Skittles, etc. Okay, and then we're going to look for evidence that contradicts that initial assumption. All right, so I'm going to erase this, and what I'm going to do is I'm going to make a box. Okay, I'm going to make a table of boxes, one for each color. Now, it turns out I was correct. There are 5 colors of Skittles. So I'm going to make a rectangle here and divide this into one box for each color. So I'm going to go, this is going to be green, red, yellow, purple, and orange. Okay, now what I am going to do now is I'm going to fill in how many Skittles of each color there are. Alright, now again, this might take a minute. Red is 2, 4, 6, 8, 10, 12, 14 red Skittles. So I put a 14 right in the middle of that box. Orange, 2, 4, 6, 8, 10, 12, 14. So we have a tie. Okay, between the red and the orange, they're tied. Now let's go with yellow. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. Yellow. So put a 23 right there. So yellow is winning for the moment. Purple is what I'm doing now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 purple. And then finally green. Okay. Green, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. Okay. Now, once I have that complete, okay, I mean, I haven't done really any thinking yet or any math yet. The next thing I'm going to do is I'm simply going to add up and see how many total Skittles I have. I have no idea. So 25 plus 14 is 39. 39 plus 23, I believe, is 62. Plus 20 is 82. Plus 14 is 96. So it looks like I have 96 Skittles. All right. Now, what I have to do is I have to determine if my initial assumption is true. If indeed the Skittle, I don't know what company makes Skittles.
Skittles makes Skittles.
There's not like a parent company or something. I bet there is.
I think there is too.
Okay. Yeah, I don't know what it's called. Something for you to do, Ted. You can look that up later. If the initial assumption that the company makes an equal number of each color of Skittle is true, well, how many of these would we expect to be green? How many would we expect to be red? How many would we expect to be yellow, etc.? Well, if they make the same number of each Skittle, we would expect that the numbers in these boxes would be approximately the same. Okay? Each one of these numbers right now is called an observed cell count. What I'm going to do now is I'm going to put new numbers, little numbers, up in the right-hand corner of the boxes. They're going to be called the expected cell counts. If my initial assumption is true, I would expect this many. Okay, I haven't figured out how much it is yet, but I would expect this many of each color of Skittle. So I've got a calculator, and of course there's 96 Skittles. If my initial assumption is true, I would expect there to be, a fifth of them to be green, a fifth of them to be red, etc. So 96 divided by 5 is 19.2. And so what I'm going to do is I'm going to write 19.2 those are the expected cell counts. Now, depending on your situation, the expected cell counts might not be the same. Okay, you have to look at the context of your problem. Maybe after a while we'll do a different problem where the expected cell counts are not the same. But just know that this little number right here is called the expected cell count. that's the number of skills we'd expect to be in each category if our initial assumption is true. Teddy, how are we doing time wise?
15 minutes.
Alright, tell you what, let's cut this off, but I'll be right back with the second half of this video. Thanks for watching. See you in a minute.